This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Yeah, good morning. Yeah, anyway, thanks for coming for this extra lecture. Yeah, I thought I will spend some time on exam practice questions because the ESD exam is a little bit different. So for the ESD, this was the structure for 2018 and we will be following the same structure for 2019. Multiple choice questions, no negative mark. But please don't guess, at least do some calculation. So there will be 10 questions, multiple choice. So I have got a couple of examples. Then short answer questions and system level questions. See, both are kind of combined. Short answer questions will be asked from your slides. So whatever I taught, from the slides I will be asking some short answer questions. I have got example. System level questions. So there will be some questions, we will be giving some problem, then you have to find out system, how to design it. And in your design, we might ask you to draw the block level diagram, and then sometimes we will ask you to draw the circuit inside some of the blocks, not all of the blocks. Then DSO question with subsections from the project. See, DSO questions are there, so there will be a DSO question. So I can show you some example we asked in the past. So again, the front page, you will see something like this. It will be 2019. This time it is a closed book exam. You can bring either FX82 or FX100. That is fine. And yeah, around same number this year as well. Same number means 10 questions are multiple choice. So basically you got only 7 questions, big questions. And you can see the multiple choice, 10 marks, something like that. But then this will be little bit, 10 marks same, but then system level questions, 55 marks. Again, this will be slightly only different this year, but almost same. DSO question, 45. Then this is add up to 110, and then we will be taking half of that one. So multiple choice, you can get 5 marks, those are easy marks. And from DSO, around 45. 40 to 45 maybe, and then if it is say 45, how much you are getting? Around 23. So 23 mark is from DSO. So if you know DSO and multiple choice, you are getting almost kind of close to 30. See? So DSO, if you don't know DSO pretty well, then system level 55, 25, yeah, still you may pass. But that will be difficult, I can tell you. Because system level, all the system level questions are not going to be easy. There will be some tough questions because we want to find out who understood really well the system level. So DSO is must. You should understand the DSO, each block what it is doing, why we asked you that specification. Think about the signal, which I already discussed. The signal is coming, what is happening after going through each block. Just think about it. Then you don't have to memorize this block level diagram. The block level diagram of DSO we will be providing actually, just to let you know so that you can save your time. So this block level diagram, whenever there is a question related to DSO, so we will give this block level diagram, see, so that you can look at the block level diagram and then you can think about it. So there is no excuse not remembering the block level diagram for not answering any DSO question. So we are giving you, maximum possible information. So multiple choice. So this is one example. The following is the, so multiple choice. So then this is one example. The following is the output stage of a bigger circuit. Okay, so this is some bigger circuit, output stage. The turn on voltage of Q1 and Q2 is 0.67 volt. So turn on voltage, in order to turn on this transistor and this transistor, you need 0.67 volt. What is the maximum voltage across R2? So that's the question. Then we have given you 132 volt, 130, 13.4, 13, 14. And the solution, what is the solution? But this circuit is a current limiter. Definitely we studied current limiter. The maximum voltage is determined by the maximum allowable current through the load. So this load. The current through R1 before Q1 turn on is 0.67 volt divided by 50 ohm, because that is this 50 ohm, is equal to 13.4 milliamps. So maximum voltage across maximum voltage occurs at maximum current is 13.4 milliamps into 1 kilo ohm, because that is the current, then that's equal to 13.4 volt. You know what I mean? So it's very easy. So you can see, you can calculate. So for DSO, what you have to be careful is when you read a question, just think about it, and then only you answer, because you got plenty of time. Yeah, so trust me, if you don't think it, you will make a mistake. You don't have to hurry. Think about it and answer. Even you can write, derive, think logically. In the electronics, when you are deriving, you got only a +5 supply, and then -5 supply for your op amp, and then you are doing some calculation, then you are getting -30 volt as answer. Obviously, it is a mistake. So that you have to apply electronics. The trick is you have to apply your knowledge in the light of logic for the electronics. So logically also you have to think. For example, here 134 volt easily you can rule out. You know what I mean? So if you logically think, 130 volt you can easily rule out. See, already 2 gone. If you logically think even before the calculation, then you are around this one. So then when you do some calculation, definitely you can find out. So logic, please apply some logic. In the electronics, that is important. So this one we asked in one of the past exams. Still some of the students made a mistake. So that's the reason why they made a mistake is they did not do calculation, they did not think. Then another one, this also some students made a mistake. What is the minimum required internal gain of an op amp used in a buffer amplifier? So you are using op amp as a buffer amplifier if the output is at least 99% of the input. You know what I meant? Yeah, so when you have this question, so if I were you, I will try to draw it. So that's another way of, if the circuit is not given, in order to make sense, always just draw it. So what he's saying is op amp is used as a buffer. So what do you mean by buffer? So then you should know what is a buffer. See, what is the minimum required internal gain of an op amp used in a buffer amplifier circuit if the output is to be at least 99% of input? The question is, you got an operation amplifier, so you are making a buffer. Then you got some voltage here, V in. Then you want here, for ideal op amp, when you have V in, you also will get maybe V in here. But then if it is not ideal, you will not get exactly V in here. Then it will be some percentage of V in will be coming. So the question is, here you need 99.99 into V in. So the solution, so what is the solution? Your V out. So V out, which is equal to A into V in minus V out. So V out by V in, which is equal to A by 1 plus A. So A by 1 plus A equal to 0.99. So it needs to be around 99. So it's very simple. So that's how you have to draw it, and then if it is a block level diagram, please try to draw the block level diagram, think about it, then only please answer. So please don't rush, you may make mistake. And also even in the system level question, when you hear some system level questions, when you read it, you might think that, oh my goodness, what is this one? Then the trick is you read line by line and draw a block level diagram. Then you think it. You know what I meant? Then you will be able to answer it. So if when there is a requirement, then you can read it. After reading each sentence, you see whether you can draw a block level diagram, and then you can answer it. That's how you should be answering. Then another multiple choice. What might ground planes be separated and connected via net tie? See, basically in a wide way you are using a net tie to save cost, to separate noise evenly between ground planes to reduce the corruption due to noise, to shorten the return path for power supply for each ground plane, to isolate noise from sensitive electronics. to reduce the weight of the PCB. See, if you apply logic, most of them gone. So solution D. Even without without learning about the net tie, many people can answer this one. But then this also some students made a mistake. So that's the reason in the final exam you have to be careful, don't get tensed and you take time. Yep.
Because it's saying that it's a multiple choice question, and notice that they all single choices so far. So it means that if I thought that there's two more answers might be correct, should I just put out two answers?
Yeah, two answers here. Yeah, most of the time we put only one multiple choice. Yeah. But if all are there, you can write D, all above, something like that. Then you can write D answer. Yeah, so no, you don't have to write B and C. There will not be like that. There will not be two correct answers. You know what I meant? Yeah. So to his question is yes, that's a good question. So there is a question. Okay, this is a net tie. Then now we got only one answer D. So his question is whether there will be any question which has two answers. Then whether you have to write C and D. No, there will be only one. You can write only D or C, only one. Only exception will be like operation amplifier got following characteristics. Then maybe high gain, then high input impedance, low output impedance, and above all. Then again you can write above all because this got all, that is only one exemption. Otherwise only one answer. Please don't write C and D, only one. Yeah, I have written couple of sentences sometimes for just more explanation. Otherwise you can just pick it up. Sensitive electronics, to isolate noise from sensitive electronics. Number of comparators in a 4-bit flash ADC, very simple. See, 4-bit flash ADC. So that is 2 raised to n minus 1 comparators. So that is equal to 15. So this also some students made a mistake. So that's the reason why they made a mistake is maybe they haven't thought about it. Sometimes if you are in a hurry, 4-bit, maybe 4, something like that, they just ticked it. Yeah, many ticked. So here I noted this question, though it was evaluated by one of the tutors, but we checked the question. So for this question, I think most of the students answered 4. I don't know why. But if you answer this 4, then I can think when the system level questions will be completely wrong because we will be asking some comparator or something. Here itself, if you make mistake, means the preparation was not sufficient. Then short question we asked, what is a Schmitt trigger? Why is a Schmitt trigger superior to a simple comparator? So this was a short question we asked I think 2 years ago. A comparator with hysteresis is called a Schmitt trigger. Or you can say that a comparator you connect a positive feedback, whatever, you can draw the circuit. And then a Schmitt trigger, why it is superior to a comparator? Because sometimes the input signal is to a comparator may vary due to some noise. If you got the Schmitt trigger, it can create a band. So different way you can answer. Then you can draw some circuit, and then if you want to show some noise, you draw some noise and you can show it's up to you. Again for DSO, for the system level questions, there is no single correct answer. Your system design will be different. People design the system differently. So we will take into account all. So you don't have to worry about your design. Only please make sure that that is logically correct and makes sense. So this was another way, simple one. Design an alarm system that is to be set off when the room temperature exceeds 60 degrees. You have to design a circuit that can be connected to a temperature to voltage transducer for which 60 degrees centigrade produces a voltage V equal to 4 volt. You can represent a temperature to voltage transducer and alarm as black boxes, but you need to design a circuit connecting both black boxes. So the system is, so then once you read, again you read the question, so that the system level questions maybe you have to read it twice. So design an alarm system that is to be set off when the room temperature exceeds 60 degrees. So read the first line and then go take a pencil and then you can draw it. So your room temperature is 60 degree, then you have to turn on an alarm. You have to design a circuit that can be connected to a temperature to voltage transducer. Means you got already a sensor, that sensor will sense the temperature and then the output is voltage. So that's the reason temperature to voltage transducer, and then in that one 60 degree equal to 4 volt. Means you basically got a sensor, and in that sensor when the room temperature is 60, then you are getting a 4 volt. Then you need to set an alarm on. So you can do it in different ways. The simple way, you can do simple way, different way, I don't know, whichever way you like, you can do it. So how can we do it? Yeah, we can do a comparator, put 4 volt threshold and then connect to an alarm. So that's a simple way. So if you want to complex, if you want to make things complicated, what you can do? 4 volt you can connect to ADC, then you can sample it, and then you connect another microcontroller, and then you then write the code, then put it in a buffer. You can do so many things. It should work. That's all. Yeah, always think of a simple solution. But that also I can't say that wrong. Then you are doing a bit higher system. Then you are putting on a SD card. You are having a SPI to SD card. Then you got a display. Then you got an alarm. Yeah, that also is possible. But then obviously that also is correct. You are not going to lose any mark. But that may be a sophisticated system than the question. Yeah, this is a simple thing. So you can draw a comparator, and then so that's all. 0.5. And see, so we will be putting mark. You can see this one 0.4 mark, this one is 2 marks, this one is 0.5 marks. So your people who are evaluating the exam, so there is a rubric. So it's not like a random. For system level questions, we will be having a flexible rubric. But these type questions, if you are doing like this, we will check if somebody is drawing one box alarm, then we might not give you the mark because we already given the alarm. Because for the system level, I have seen some students, when they came for the exam viewing, they have drawn some blocks for every system. Front end, something, processing. So you might not get some mark for that because everybody knows that from the question you can get some blocks. Then you just draw it. But that block is good. No, I appreciate them because they attempted. That block is good for thinking. You also should be drawing after reading each line, what are the blocks. Then you can think of how to connect it and make the system. But then that alone will not give any marks, I must say that at the beginning, because that already in the question you are just drawing. So your job is, converting writing into some drawing. But that is good. That is a starting point to answer the question. So somebody also done like this, using a Schmidt trigger, then use a buzzer here. So many ways, you can do it. As long as your logic is working, that is fine. Then, this one we asked several years, so that's actually draw block level diagram of your DSO and explain its working. So this year we are giving you the DSO block level diagram, and then we will be asking. Yeah, so this question we asked in different ways in a couple of years. DSO has a trigger and it plays a very important function. Without the trigger, the DSO would not be able to function properly. Please explain why DSO has a trigger. So that you can write it, you can draw some signal, it's up to you how to write it. So always when you write another thing, when you write an exam, getting the marks is not that easy. You need some skill. When you are communicating to someone or somebody is evaluating your knowledge, so please write all the details, all the steps. Because there will be a rubric, then they will be checking with the rubric whether they answered this part, this part, this part. So most of the time, if somebody evaluated like ECD or ESD, and if I give you an appointment, then I give you the rubric usually. If your mark difference is big, you got so many questions, and then in one occasion, when the student evaluated with his own exam with respect to the rubric, it was less by 3 marks. So that's the reason we make a rubric so that it is a fair one. Because if you don't have a rubric, what will happen is you don't like plus sign becoming negative. So you will, oh, that is really stupid mistake. I will reduce 9 mark out of 10. But then for me, that is not a big thing. Depending upon the people who are evaluating, that's the reason we got a standard rubric for my exams, even most of the exams, so that there is a consistency in marking. So DSO trigger, then you should explain why DSO as a trigger. Obviously now you know that DSO got trigger. If you don't have the trigger, what will happen is you can't, the signal will not stay there. You will be having one signal displaying, then another time it will be starting from some other place, and then you will not see like a standing form. Like, you know what I meant? We already discussed the trigger, and then if you don't know trigger, even I uploaded some extra material on LMS, the drawing, the sketches. And another one. If you upgrade your DSO sampling rate from 40 mega samples per second to support the new ADC maximum sampling rate of 125 mega samples per second, some key changes are required within various sections of your system architecture. Identify from the simplified DSO architecture outlined in figure. I will show you the figure. Which two blocks will require upgrading to support this new sampling rate, and briefly describe in your own words why these elements will need to be changed. Hint: assume that RAMs, CPLD and counters are all adequately specified to operate at higher clock frequencies required by the new sampling rate. Means your DSO, you are operating at 40 mega samples per second, then we got a new ADC that is operating at 125 mega samples per second. So we are going to replace it. So the question is, what are the modifications required? But then obviously you have to do a lot of modification, but then we already said we got the digital part ready. RAM, CPLD, counters, all are specified. Then that can handle 125 mega samples per second. Then obviously then now you got the hint. You have to modify the front end. And in the front end, then what you will modify? If you write BNC, that's not the correct answer. Then what are the things you will be modifying? Yeah, so anti-aliasing filter is one important part. And then analog front end. The increased sampling rate also requires changes to the anti-aliasing filter, because that is an important thing to suppress the noise. To ensure the frequency components above the new higher Nyquist frequency are removed from the signal entering the ADC's analog input. So that's the reason you have to read the question carefully. See, it said identify from the simplified DSO architecture the new sampling rate, briefly describe in your own words why these elements will need to be changed. So please don't write it. So that's the reason, please read your questions carefully, each line. Then then you might write only one line. Yeah, we need to change anti-aliasing filter, but then you will get only 1 mark. So please read the question carefully. That is the one thing I want to insist. It's based on my experience. I have seen so many answers, different things we discussed with so I will not be marking your exam, but I will be closely involved in marking. If there is a question, confusion, some things we discuss. So the marking will be done by at least 2 people will check it. So there will not be any mistake usually, it will not happen actually. Marking will be thoroughly, it's a thorough marking by multiple people. Then we also discuss marking. So because I teach this subject from 2015, so I have seen many answers, interesting answers. So that's the reason. So I want to, I specially booked this exam to say, I want to show you the exam style, template, some questions. Plus this point I want to insist again, please read each line in the question. So that is a mistake I have seen with the students. They haven't seen the line, why need explanation? So please read every line carefully and then answer. So here, most of the time this question, when we evaluated, we also prepare an Excel sheet, because there is a board of examiners meeting, we will be discussing the exam. And then we always tabulate which question they performed really well, which one they didn't. And then this question, many didn't get good marks actually, because they only wrote like 1 line. So then the explanation. So that's the reason. Here see, analog front end. Increased sampling rate also requires changes to the anti-aliasing filter to ensure the frequency components above the new higher Nyquist frequency are removed from the signal entering the ADC's input. PLL, the frequency of the system driven the ADC, CPLD and the counter must increase from 40 MHz to 120 MHz. So CPLD, please don't forget, because whatever you are connecting to the analog front end, you have to change it. Then bonus, or a change of complete microcontroller to one which they send out a higher base frequency, assuming the PLL can lock to the 125 MHz signal would generate at its output. But then you don't need this one. You need at least this analog front end. Then you have to say anti-aliasing filter. Then you have to say that PLL. And then why PLL? Because you need to increase the system driving ADC, CPLD and the counters must increase from 40 to 120 megahertz. So that's all. Then this increase necessitates a change of PLL to one with a higher clock multiplier. That's all. It's a simple answer. So the 2018, so this was the breakup. Again I have shown 10% from 110 marks. So 10 or 55% out of 55, 10% is from multiple choice, and the short answer was around 50, and the DSO question was around 40. So this will vary between 40 and 45. Depending on this will reduce or increase. And so if you understood DSO well, you will be definitely able to answer the system level questions. So if you know DSO very well, you can give the exam today actually. Because if you know DSO, definitely you will be able to get DSO, you will be able to answer system level questions. All the lectures what I have covered is related to DSO. So PLL, all the things, amplifier, filter, everything is connected related to DSO. So then you also will be able to answer multiple choice questions. A formula sheet will be given at the end of the question paper. For I don't think you need a formula sheet for ESD because there is no calculations. But still we have attached a formula sheet. If you need a formula sheet, then if any, I will be there for some time, maybe 1 hour, I don't know, depending upon our availability, but definitely I will be there. And so you please ask me any questions while reading, if you got some question, what is this one? So I will be happy to answer. Please don't ask me to answer it on the paper. So I will give you more explanation. Again, like ECD, you will be writing your answers on the box, so that there is no separate page. Rather, you will be writing on the box. So these are some examples I got from past years. But you can also find some exams on the library. You know that one? Library. If you check library, and then past exam, and there are some question papers. So please look only from 2015, because syllabus was different, I think, previously. 2015, 16, some 2-3 years you can look at it.
Is this an ACD question or an ESD question?
Oh, this is just an example, it's from ECD, because we will be using the same template, like ECD. So that's the reason I used the ECD question. But then ECD also you should be knowing. So, because if you can't answer ECD, we will be reducing double marks, because that was a prerequisite. No, I'm just joking. Yeah, this is means what I have shown is we are using the same template, so that you can write in the box. So any other questions you have got related to the exam, please ask me. So I think one system level question we asked, I think I discussed during the previous lectures. See, maybe the system level question will be like this. You are working as an engineer in a company, and so there is a requirement to maybe measure the reflectivity of this wood, reflectivity of different wood, and then store the information in SD card or somewhere, something like that. How will you design the system? You know the question. measure the reflectivity of different wood surfaces, and then design a system to measure the reflectivity of different wood surfaces and then store the data in SD card. Then we will say you will be given laser diode, you will be given some photodetectors. So we will give you some, then remaining these things you can use as a block level. Remaining you have to draw the block level and then circuit. So how will you do? So then I heard that, so then how I will be thinking as a student, okay, so we have to measure the reflectivity of different wood surfaces and then store it in SD card. And then laser is given, photodetector is given. So then laser you can use as a block. Then what I will do is immediately I will draw the laser. So then I got the laser. From the laser I will putting different wood surfaces, I will be drawing something like that. Then maybe some is reflected or scattered, then there will be a photodetector, and then so then I am getting the signal. Then definitely I know that this is I, then maybe this is I dash, and then so I can measure the voltage, and then different wood got different reflectivity. So different reflectivity. So this much is clear. Then after photodetector, again your ESD knowledge, DSO knowledge will kick in. So after photodetector, so this photodetector again we will clearly tell you the photodetector output is voltage. Usually photodetector will have current, and then you need a current voltage, but we will tell you photodetector got voltage low. Maybe we will not say that, we will say this photodetector output is 10 microvolt range. Then what the meaning is, you need an amplifier, So other we will not tell that one. You should be a then 10 microvolt is, then you need an amplifier. So I will putting in an amplifier block. Then also maybe you can put a filter block so that you can remove some noise. Then what are the blocks? Yeah. So you need to sample the data because you need to store it ADC. And then you can write a clock also here. Then you don't need to specify which ADC. Then you can say that, okay, this is ADC output. Then after ADC, what do you need? Okay, you are putting a digital buffer. Yeah, that's fine. Buffer, because you have to write it into SD card. So how will you write it?
How do you interface with the SD card?
Sorry?
Can you interface by parallel with the SD card, or is it SPI?
Anything you can use.
So could you use some clocks on the buffer and have it go straight into the ADC card without using it?
So what we want to do is, so you got the clock here. So you need definitely an SD card here is there. So what you said is you got the clock, ADC clock, and then you got a buffer. You are storing anyway in the digital buffer.
I think the clock is much more faster than the SPI's clock, because the ADC clock is much more faster, and the SPI clock should be slower.
Yeah, that's fine. All the slow these things we are just understanding what are the blocks required, because we are not yes, definitely we have to think of the speed when you are drawing the circuit, but this is only the system level, what each block does.
So then from the buffer into like an MCU,
Yep.
which then is like SPI or IGC into
Yep, that's all. So SPI, and then you got the SD card. So that's all. This is a correct block level diagram. So it's related. So I would like thinking in the line of DSO. That's good. So that because every system you got a front end, then the analog signal you need an ADC. Once you got ADC, put a digital, then you need a microcontroller that will with the interface SPI, or you can connect to the clock or whatever you wanted to do. So that is the whole system. That is the backbone of all the systems. That's the system engineer you should be knowing. Then you will be able to answer. Then that's all. This one itself, carry maybe 8 marks. See, full system level diagram. Then we will not ask you to draw ADC clock or anything. We might ask the amplifier, draw the circuit diagram for the amplifier, or which filter you will be using. Draw some circuit diagram without any values. Yep.
I mean, the filter should be before the amplifier.
Yeah, you can put an amplifier before as well, but then the signal level is very, very small.
But it will be amplify the noise.
Yeah, that's fine. You can put it before as well. But always it might not be possible. Why? Because in some cases, when you put your filter, the filter also can introduce some noise. There's a circuit, power supply noises if it is very, very small. So then people little bit amplify. So that's the reason the concept of a pre-amplifier. Then they use a pre-amplifier, is means a little bit only it will amplify, and then they will filter it and then further amplify. Yeah, you can put it. Yeah, these things are fine. As long as things are there, that is fine. So ADC, whenever you got ADC, better to have a low pass filter before that, because you want to make sure that the noise is not going to the ADC, and then you give errors, aliasing. You don't want aliasing. And then so this was the question, and then this one carries if it is for say 18 marks, maybe 10 marks will be for this one, maybe 8 marks. And then out of 8, 4 marks will be for the amplifier design, 4 marks will be for the filter design, something like that. If the question is like that, design the circuit inside amplifier block and filter block, then there will be like 4 marks. So these are the way you should be answering. So see, when you heard this one, when you read it, reflectivity and all, then you might be thinking, so better to draw it and think about it, and then think about the block. Then also you should visualize, okay, light is coming from the laser, and it is hitting, and then it is coming to the photodetector, output is voltage, you need an amplifier. So you need that kind of a visualization as a system engineer, how the system is working. So that's a thing. So there will be consultation next week in my office. So if you have any questions, please come and see me. And some formula sheet, I don't think you need any formula sheet for ESD this year, but these are the formula sheet and example. Yeah. Sorry. Yeah, I don't think you need any formula sheet this year, because all the questions are related to systems and DSO, even short answer questions. You don't need any of these formulas actually this year, but still we are providing you this formula, because some of you may like formulas. When you are sad, you look at the formulas and you will be happy. Especially if you like maths, you might not like electronics, but you are learning electronics, you want to learn it, but then you are happy, if you want to see equations, then you can look at the equation. Like if some questions you can't answer about bandwidth or something, then you saw this equation, oh yeah, I'm very happy, this equation is there. Yeah, yes please.
So we won't have to design a set of butterworks or anything like that with values.
Usually we don't ask such questions because that is time consuming. Yeah, if the question is there, we will say draw the Butterworth filter. Then you can draw and put in the value R, C, but then we will not ask you to design it, because that questions are time consuming. Yeah. So we will be having enough time, because when we set the exam, we will be putting a good margin so that you can think, and because it's not about quickly answering, it's checking your thinking ability, and because filter design usually we don't ask. Why? Because there are standard good software, what is happening. Yeah, some questions we don't ask you to calculate unless it is possible in a short time period. If it is time consuming, we can't ask that questions. Yeah, so we give you plenty of formula, like if resonance frequency, though it is not written. So finally I want to hear from you on the SCS, and if you have any feedback, please let us know. But if you write my shirt is not good, you have to buy me one. But if you write something good, means constructive in the sense what can be improved, I will really appreciate. I like hearing from you, because many things I incorporated after hearing from you guys like students. Because when I started in 2015, we did not provide the block level diagrams of the DSO. You can check with maybe people who completed 2 years ago. We did not provide any information, but then they wrote, we need a bit more, help in the terms of something. They didn't say block level, but then we came up with the idea, oh yeah, block level diagram is good. And again, some syllabus, some part they recommended, so we included accordingly. some part we modified. Then some more sections we included. Then some students gave me feedback. They wanted to, some communication protocol. Then I thought, oh, it made sense. Definitely, all the guys, require that one. So something, if you got something, good things, we can improve. Definitely, I'm happy. I wouldn't say that this is perfect. Every year we get feedback, we incorporate, collect it, and then we want to improve it for next year. So please, fill in your SES. And then extra exam consultations. There will be 2 extra exam consultations next week. So what I would recommend is, if you got any questions, please come and see me. Especially, please go through maybe some past exams, and then we can have a chat. Then if you can't come during this time, if you are not in the campus or around, you can email me your questions, or you can email me and find a time for meeting. So please don't come and see me. When is your ESD exam? What time? 8 a.m. Okay, 8 a.m. is good. If it is in the afternoon, I got some students came and saw me in the morning. Okay, so that's not a good idea. And because I don't think that information is going to be any useful, to be honest. So if you have any questions, you can come and see me even on 21st. Yeah, I think I'll be in my office. And then, but email me so that I'll be there. I'll come and see you. But make use of this consultation. Plus, I will be available over email. And also, you can book an appointment with me to discuss the questions. So better to book an appointment and discuss with me, because email will be a bit complicated. Sometimes some system level questions if you have got it. And then if you are sending some images, please make sure that you can see yourself before sending. Because sometimes you send the photo, I won't be able to download it to some format, or I can't see properly. So you please download and check it whether it is correct. Like for example, you answered some questions, then make sure that you can open it and see, then you please send me. And also big attachments might not pass through our uni email, so it should not be in a couple of MBs. PDF, maybe compress it and send me. So what I said is, please don't send me directly from your phone, because that memory, your phone might have high resolution. That high resolution might not come through. So convert into PDF or then send me. Yeah, these times I think I put it already on LMS, and then maybe I can put it as an extra PDF so that you will know that next Wednesday and then Thursday. Then that's all. Thank you. Then for your lab, we have got times. I am going to announce it. So we have got, I think, 4 sessions or 5 sessions running. So some sessions are that is happening around 12 during the exam, couple of sessions. Then after the exam, I think 2 sessions, because your exam is finishing on 22nd. That is Friday. I think we got a session on Monday. So that if you are not finishing your DSO, still you got the time. So how many of you finished? Because I have seen some of you already finishing DSO. How many finished your DSO? How many students finished your DSOs? You finished, okay. Yeah, I know that some of you already finished. So you guys are free. And so DSO also, I'm happy to discuss any questions. DSO, any questions during this time. And that's all. Thank you, and pleasure teaching you all.
Because here, I think I got lost. Here, it requires us to draw block diagrams of my DSO. So every block diagram is a GBA?
Yeah, that was what it said.
Every block diagram?
This whole block.
Explain everyone.
Yeah. Because this was only question. And then that carried like 20-25 marks or something. Yeah, not like 5 marks and it's like.
And you said they have a trigger, right? It's a very important function. Well, I think that the trigger is to set the starting point of sampling, right?
So if you don't have to say, what will happen?
That's the only words I can think of.
So it will be displaying like this.
Yeah.
Next time, it will not start from here. It will display like this.
What do you mean?
The origin will not be coinciding here.
Pardon?
So when you have DS trigger, if you don't have trigger, what will happen is your first signal will be displayed like this.
Yes.
The next time the signal will not start from here. It will start maybe from here. It will be starting same trick like this. Again it will be starting maybe somewhere from here. You know what I mean? So there is no starting point.
Then starting point.
Yeah. Otherwise it will be starting like this.
Okay.
Yeah. Sometimes.
Just to fix the starting point, right?
Okay. But why, if you follow trigger, why you said that it will have a starting point?
Yeah, because of that you are setting. That above that voltage will be sampling.
I mean, if we follow trigger, right? Why you still have the signal? I think that if we follow trigger signal, it would not have any signal like that. It would be blank. I think that if we follow trigger, if we follow the trigger, I don't think we have any signal.
No, without trigger also you can get something.
Also get something.
Yeah. Because that's the reason force of in your DS.
Of false trigger.
Yeah.
Oh, okay.
Yeah, I just have one question. With the bonus marks, can we still get bonus marks next week, or is it only in week 12?
No. You can show your bonus marks until the completion date.
Okay, cool.
Yeah,
Yeah, because in the project introduction it said the bonus marks were only in week
So
12.
also I will be sending out another email if you got any questions related to your marks.
Yeah.
Because I think someone emailed me some marks something checked 1 or 2 students.
Yeah.
So you can come and see me.
No, mine are fine
Everything
for
fine.
the first
Okay,
two
okay,
parts. Yeah, because I finished my DSO, but I want to put it in a screen in a case. So that will take me another...
No, that's fine. Yeah. Free. I think you got time. You can go to Monday and show your.
Yeah. Okay, great. Okay. Is the next session on Monday?
No. Monday means even after the exam you can.
Oh, right. Okay,
Or if
okay.
you got during the exam, I'm going to post it. The
Yeah.
timings today.
Okay, great. Thank you.
You mean we have two lecture workshops set during the exam, and after the exam we also have two workshops
Maybe after the exam, maybe you got full Monday.
for Monday.
Yeah. After the exam, Monday, and then before that you may have got 3 sessions.
Oh, okay. And we can do the presentation
Any session.
on last day, the Monday.
Or any session before that. If you want, you can do on Monday.
Oh, okay. And I also received the email from me says the copy question, and it's at 2 p.m.
Yeah. Please come. 2 p.m. we'll be meeting. Yeah.
Okay.
Yeah, I'll see you.
Okay, see you.
Please wait. Yeah. No. I'll come to the mayor.
Actually, I didn't understand the electronic program. Do you mean the DC code?
No. So all the supplementation signals. No current means that there is no DC signal. Yeah, because you are passing, your light is going, because current is not passing as electrons. Like current is passing as through some other process. So like when you got optocoupler, your LED is on, and then the light is going, and then it is hitting the detector. Then the current is generated. So across there is no electric current is flowing, but the current is flowing through optically.
But what about the exchange of signals? Where the electrons?
Yeah, so this one what we meant is, so when you got a galvanic isolation, so this is one side, so this is a +5, this is a +5, then this one got maybe digital, analog, this is a ground digital, this is a ground analog. So galvanic means no connection at all. Then what galvanic does is, from here you may be having a optocoupler. In the optocoupler you got LED. Okay. So LED is lighting, and then you are just receiving in a photodetector, and then you are getting some current, and then you got a pull up. So across this one actually no direct current is flowing, electrons. You know what I meant? It's optically going. That could be DC or signal, both. It means saying that in the across this one, your electrons are not flowing. So that's the reason we also wrote electrons. But it's optically it is transferred. Okay.
I'm not sure I was opening this part. Previously, this then this point will just be V plus. But what about this transistor is on?
Yeah, the transistor is on the so this is your V I R R. So then your this transistor will be on. Then your VCC equal to ICRC plus VC. So then your this voltage will become VC, which is equal to VCC minus IC to RC.
Yeah, but I think you in the lecture you said when this is on, then this point is tied to V plus. I think this is when this is off, then this point tied to.
Oh, there's not that tying called pull up. So that tying is called pull up. You know, we'll be pulling up.
Yeah.
Yeah. So this one is this is also kind of, you can say, pull up, because you are pulling up to this voltage. But then here you got two functions. One is pulling up, and then it's because there is a transistor.
Yeah.
Then this also serving as your load resistor.
So is the collector resistor.
Yeah, collector resistor. Yeah.
So I think it's actually when this is off, then this point is tied to
VC. Yeah. So then this one is mainly used for communicating some signals, because when your signal is coming, then this voltage will decrease, and then when signal is not there, this voltage will increase, so that you can get a pulse. You know what I mean? Yeah. So depending upon which is the application, DC or AC signal passing through, then you will be changing the connections accordingly. Sometimes, yeah, you know what I meant?
Yeah.
Yep.
So the exchange of so it's through optical process.
Optical process. No electrons are flowing. Yeah. That's the reason we wrote here that. Okay. Anyway, good. Congratulations. I'm very happy that you got the merit, because last year also got the merit. So usually they don't give you a merit.
Yeah.
Because the consecutive years